Kia ora koutou, ko Rachel McIntyre toku ingoa, Strategic Sustainability Advisor. It's fantastic to be back hosting the 5th webinar in the Demystifying Carbon Series. Today we're introducing the National Embodied Carbon Data Repository for Construction, a free, authoritative online database which will help architects design out carbon emissions in buildings in Aotearoa, New Zealand. The Carbon Database is a united effort from NZIA, Master Builders, CIL Masterspec and BRANZ. We're united in providing reliable, accessible data to support better decision making. And we're united in providing architects and industry with the tools to integrate carbon accounting into their project planning. I'm thrilled to be joined by Mike Jackson, General Manager, Construction Specification from Masterspec. Mike is also a valued member of the NZIA and a registered architect. We're also joined by Jared Butler, a building environmental scientist from BRANZ. So welcome to you both. I'd also like to thank our sponsors, LMA Timber and Kingspan Thermacraft, for sponsoring this webinar series. Through these discussions, we're beginning to connect the newly introduced award sustainability criteria. And again, the section that we're referring to today is the whakapapa building materials and processes section. We're asking for data from lifecycle assessments that have been carried out during the design process. And the aim of these questions is to 1, build your knowledge and skills in lifecycle assessments and carbon accounting, and 2, to encourage architects to be leaders in the field of carbon reduction efforts. Yeah, I showed this slide in the last webinar that we had, but I think it's good to reiterate the technical resources ecosystem around carbon that's happening in New Zealand, and it's constantly evolving and expanding. And the carbon database is a critical and central part of this ecosystem. So that's it from me for now. So now I'll hand over to you, Mike, to start your presentation. Thanks.
Thank you. Yeah, thanks, Rachel, and thanks to the NZIA for the opportunity to present on this subject, and also to the people who have spoke in the series before us who have really set the scene. We'll recap on a few things, but quickly drop into what we're doing with the database. Firstly, introducing CIL, Construction Information Limited. We're better known to the industry as Masterspec. That's our strong product around specifications. We're the commercial arm of the NZIA and registered master builders, both of them our shareholders, and we're 100% industry owned and construction sector focused. Trusted provider of technical content since the mid-1990s, and what we've offered over that time has come a long way, from hard copy Word document specifications to where we are now with cloud-based online systems. We're used by the majority of New Zealand's design professionals, in excess of 75% registered architects and practices. We maintain a comprehensive digital content for access by the industry. The new initiative, which you can see from the little diagram there, that's what we do. The National Embodied Carbon Repository will be curated by CIL, and it will just be building on the existing data that we currently provide. Next slide. So on behalf of BRANZ, I'll introduce them just so we have a bit of continuity. These are the key principles in this image that drive BRANZ. Their focus areas around affordability, resilience, sustainability and quality. This was reiterated, I think, about 6 or 8 weeks ago down in Parliament at the release of the plan going forward for BRANZ. They provide practical research, testing and assurance services to improve the built environment and New Zealanders' lives. and they maintain an independence in the work that they do. And they've been conducting research for the last 12 years on the embodied carbon and life cycle assessments to where we are now. It's been quite a long 12-year journey. Next slide, please. So the challenge, December 2024, the government released its second emissions reduction plan, and that outlines the targets for the next period, 2026 to 2030. It reaffirms New Zealand's commitment to net zero carbon by 2050. Buildings contribute around 12% of domestic greenhouse gas emissions. Operationally, around 9% embodied carbon emissions, down at 4%. But that's the number there that we're focused on getting down, particularly with this data repository. Key action for the government is to work with industry to get this emissions data out there for the building products materials for better decision making by the industry. And the quote from the government down the bottom there in that document, they fully support the work that BRANZ and Masterspec are doing with this online resource for embodied carbon data. Next slide, please. So about informed choices, the path to net zero relies on smarter material choices, efficient systems and integrated sustainability right from the start of the project through the whole process of construction to the delivery completion. This little diagram shows quite nicely the upfront carbon, where the influence is. Architects have a key role in this part of the process. The other one just below that, engineers. This little graphic comes from Cove in the US. They say low for engineers. We actually disagree. We think this might be a US sort of slant on it, but in the New Zealand environment, engineers have a key part to play. We'd suggest structural engineers around concrete, steel, mechanical engineers around efficient air conditioning systems, electrical, etc., etc. So look, we see making these smart and informed design decisions right up front is key. As you see, the architects have slightly less impact through the operational side once the project's going through its life cycle. But then again, at the end, how the building is dealt with through deconstruction, etc., is another high impact. Next slide. So the CIL BRANZ partnership, we at Masterspec, CIL, we felt that this was a really good initiative. Our relationship with BRANZ that we've developed over many years, but really gone to the next level in the last year or so. We've got shared purpose, aligned values, and a commitment to a better built environment working together. The CIL collaborating with BRANZ with the MB endorsement on this project, we think is a great thing. Getting a single trusted source for embodied carbon data for the New Zealand construction sector. It's has been a little bit fragmented. Everyone has a go. We're pulling it back to one source with government support. It builds on the BRANZ data that's been developed, as we said, over the last 12 years, formerly accessed via Construct, the BRANZ tool. From mid-2025, data will be hosted on our platform and maintained under a developed and agreed methodology that we've worked on over the last 12 months. The data will be publicly available for view around the same time, mid-2025. The data will then be accessed via APIs, an abbreviation that we've heard thrown around. I need to research these things, so it's actually application programming interface. It's the bit on the data end that communicates with the tools that the architectural community will have access to do the calculations. It pulls the data through. The data is, as Rachel said earlier, free to access. It's open data. So there's a data governance role that's been set up for this traditional sort of steward and custodian arrangement, whereby the data, how the data is displayed, the rules we've worked through, but they're set by BRANZ as the steward of the data set. They're the scientists, this is their area. We will maintain and distribute the data as open data based on the methodology that is defined by the steward. The difficult questions as we go forward that are around how the data is displayed or calculated will go from us back to BRANZ for a ruling or an assessment and then communicated back to the industry. So that's kind of how the process works. Next slide. So yeah, carbon emissions in buildings, if you break it down into two areas, so we've got the operational carbon emissions, which happen during the building life cycle, during the operational part of the building, people occupying it. And they're closely linked to heating, cooling, lighting, energy and resource consumption during that life cycle. The bit that we're really interested in with this repository is the embodied carbon emissions, which comes from materials and products that make up the building. This little diagram shows it quite nicely. Again, going back to that Cove slide, up front, the product and construction phase of the project is heavily influenced by the architects, by the designers. During the project, over that period, 50, 60 years, the lifespan of the project, there are key moments where replacement and maintenance of equipment, building fabric has to happen. That control is generally sitting with the facilities management team. You want to make sure that they understand through that time what materials to replace with. So the importance of conveying that information to the FM team through manuals, etc., is really important to maintain that carbon footprint through to the end of the project. The end of life, again, has a high embodied carbon load at that point. Demolition, disposal, recycling processes. Next slide, please. So transport is such a significant part of these projects. 90% of all building materials, it's said, come from offshore into New Zealand. The transport factor is quite a significant part, moving those materials from the manufacturing plant through to the suppliers to the site. Distance, mode of transport and fuel type influence carbon impact significantly. Transport accounts for about 20% of all emissions in New Zealand, and the figures are growing. So that's a bit of an alarming number. For the purpose of calculating A4, the link to the Ministry of the Environment site is shown down below. That provides the data, the localised data for New Zealand industry for the different modes of transport. Building waste is another significant issue. If anyone's in denial about global warming, that's, you can set that aside, but actually witnessing destruction, buildings being demolished and then pushed into bins, taken to landfill, we all see it every day. Changing that behaviour is just such an important thing that we can all make a difference in, on building sites and our documentation, things that we think are desirable, and we can really make a difference. So the building waste and the embodied carbon starts at raw material extraction stage through the manufacturing and the processing of those materials. As we said, transportation from Northern Hemisphere down to the site somewhere in New Zealand, the construction and installation of that, and in turn the demolition processes later on. The end-of-life waste, putting timber especially into landfill, it just emits methane through a set period. All that benefit that you've got from using timber and the carbon that's put into that timber, it just goes back to the atmosphere. So it's going in the other direction with the carbon benefit. The loss of potential of reuse or recycling materials, if it just gets pushed into landfill, that's something we can all think about. Next slide. So circular economy potential, there are some things here, if we can just think around designing for disassembly, using reclaiming and recycling materials, modular construction, very, very difficult to get off the ground in a big way in New Zealand. We've just seen Clevercore, the Fletcher company, announcing their closing. So, we've got a huge number of challenges there. One of the biggest ones typically is around cost and not making it cost effective. Keeping materials, products in circulation as long as possible, getting extended durability out of materials if we can. It makes these buildings last longer, which is great. Waste really just equals carbon. It's as simple as that. If a building is designed to be zero carbon, but still generates a lot of waste during construction or demolition, it undermines the goal. True carbon strategy is waste minimisation, smart material choices upfront and during the project, during the lifespan of the project, and these circular design principles. So is carbon counting mandatory? Not yet. It's been promised it's coming. Regulation has been deferred. We're not sure how long, but it is coming, so we need to be prepared for it. And key things, consider sustainability early in the design process. Late decisions or changes during the project will be costly. Basically, if you make a decision early on for a particular carbon footprint for a product or system, and then there's a substitution that someone has a bright idea to save some dollars, you'll have to go back and weave that through and make sure it's an equivalent or still fits within the carbon plan that you've put together. Prioritise materials with lower embodied carbon. Design with deconstruction in mind. Facilitate reuse materials if you can. Focus on material longevity. Projects designed with a longer lifespan and easier disassembly will help to meet carbon reduction targets while reducing waste. Okay, I'll hand over to Jared at this point.
Kia ora, Mike. Thank you for that excellent overview. So I'm going to go into a bit more detail about what we're actually doing with this repository and what it's going to be. And we're going to start by defining the specific problem that we're actually trying to resolve. So ideally, we want sort of the whole industry doing carbon footprint assessments, but unfortunately, doing carbon footprint assessments and life cycle assessments or any sorts of assessments like these can be hard and time consuming to do well. Click. So it's a very data intensive process. You need to know what materials are going into your building, how much of those materials, and have environmental impact data for each of them. And then if you're working on a big commercial project where you've got potentially thousands of materials, that makes it even more challenging. And then, as Mike said, it tends to be best to do these sorts of assessments very early in the designs process when the design is still quite flexible and you can make changes. So you basically don't have most of this information during that time anyway. And then you also might be, trying to upskill on this, trying to learn how to do these sorts of things, and it's quite difficult. And you're still trying to do your main job of being an architect, and you just don't have much time to actually do this. And it all starts becoming a bit overwhelming. Click. So the way that, if you've been tuning into the previous webinars in this series, you'll know that we typically do these sorts of assessments using digital tools, which I'm going to be referring to life cycle assessment or carbon footprinting tools throughout the rest of this. And they're basically digital tools that are designed to make doing these sorts of assessments actually practical within the context of designing a building. And they're fantastic. They make the process a lot easier. They do a lot of great things, but the three key things that they do is click. Firstly, they collect a lot of environmental impact data for a range of different building materials for you, so you don't need to do that yourself. Click. They automate all the calculations so that you don't need to manually do them. Click. And they also visualize your results and present them in a way that's easy for you to interpret. So ultimately, you can use that information to inform the design of your building. Click. However, there is a sort of problem with how the current ecosystem of tools is set up, and that's they all do this data collection process separately. We're going to go into a bit more detail in the next slide, but basically there's a lot of assumptions that need to be made, and there's lots of things that could be done differently when you're doing this data collection exercise. And because each of the different tools are doing it themselves, they do some things differently, and that leads to inconsistency. So theoretically, you could model the same building and a variety of different tools, and you'd get different carbon footprints or different environmental impacts from each of those assessments. Click. So that has a number of problems, but the sort of biggest problem is that when those differences between the tools are so significant that it ends up, you result in making the wrong design decision from a sustainability perspective, and the actual building that is constructed ends up releasing more greenhouse gases into the atmosphere than it could have otherwise. And so it's really important to try and facilitate consistency and good data behind these tools. Next slide. So what is the actual thing that sort of goes wrong with this whole data collection process? Well, the main source of data that we have for the impact of construction products are these documents called environmental product declarations. And basically, they're a document where a manufacturer is declaring the environmental impact of their products manufactured at a specific time using a specific process. They are fantastic. They're probably the best source of data that we have currently. And typically tools will take data from EPDs and import them so that you don't have to go and find the PDFs yourselves and try and process them yourselves. However, there are a couple of challenges with EPDs. And one of the big ones is that they typically don't report all the information that you need, especially to do a whole life cycle assessment from manufacturing to end of life. There's usually gaps, and when the tools import these EPDs, they basically need to fill those gaps. Additionally, there isn't an EPD for every single product that's available, and there's not EPDs available for quite commonly used products, and you can't really have a functional tool or database without those commonly used products. So basically, there's a lot of situations where tools will need to develop proxy data. There's a couple of ways they do that, but the point is that there's a lot of assumptions and a lot of things that could be done differently when they're doing that, and that leads to inconsistencies between the tools because they do they fill those gaps and add in that proxy data and additional information in different ways. We also have a couple of other challenges here in Aotearoa. So unlike sort of Europe and the US, we don't have many EPDs for a lot of the products that we use. We're sort of behind in this area, or we're not as big of a market, so we don't have as many. And there's more coming out, and given time, we'll probably have quite a few, but we're still not there yet. And even if you have EPDs for similar products, there can still be inconsistencies with a lot of the assumptions that are made between them, especially for future life cycle stages. For example, things like recycling rates at end of life, or construction wastage rates, or service lives for materials. Those things can change when you don't have sort of a really robust research or scientific background to inform those assumptions, which we typically don't have here in New Zealand because the research just hasn't really been done. And also EPDs expire after 5 years, and sometimes they're not updated either, which leads to problems with maintaining data and data integrity and stuff like that. Next slide. So what's an alternative model? So basically, rather than the tools doing this data collection exercise themselves, you do this data collection exercise outside of the tools and put it into a single repository or database or a single source. And then the tools query the data and use it for themselves. And there's a number of benefits to doing this instead of the tools doing it themselves. So it facilitates consistency amongst all the different tools. So it helps resolve that issue where you might get different results from modeling the same building in different tools. And secondly, there's a lot of sort of stakeholders or professionals that may need to interact with the carbon footprinting process or the life cycle assessment process. So, you know, architects like yourselves, engineers might need to get involved. Your client might want to see some of your results or have a play with some things. And so that sort of creates the need for a diverse and broad range or ecosystem of tools that can cater to lots of people's different needs and different workflows and stuff like that. And so by having a central repository of data, it facilitates innovation. It makes it easier to develop these sorts of tools because then a tool developer doesn't need to go out and collect the data themselves. Next slide. There's actually a couple of international initiatives that are already being developed or are already released. I've given a couple of examples here. So there's one called CO2 Data from Finland. There's another one called Embodied in Germany, the Built Environment Carbon Database within the UK. And then there's Eco Platform, which is sort of more of a European/global initiative. And these databases tend to collate information from EPDs, and they may also fill gaps by developing some defaults, which is proxy data. The benefits with these ones, or the advantage that these ones have over us here in Aotearoa, is that they have a lot more EPDs available, and they're developed sort of specifically for the regions that they're developed in. So the CO2 data is kind of, you can only really use it accurately in Finland, for example. So what is the repository? We're essentially trying to do this sort of initiative and make it specifically for Aotearoa and overcome those challenges of not having many EPDs available at the moment and trying to help fix some of the inconsistencies that we've been seeing. So initially, the repository will be is based on the previous data that BRANZ has been developing for the past 12 years that was originally available in our old tool called Construct, along with a lot of assumptions and sort of New Zealand defaults from data sheets that we have available on our website. But we have gone through the process of reviewing them and currently expanding some of our defaults and expanding this a bit. Click. So it's going to start populated with a lot of BRANZ data, but going forward, we're going to be taking EPDs and other sort of LCA studies that may not be EPDs and then importing them into the database so it continually grows and keeps up with the developments that are happening in the industry. Click. But there's sort of we're developing quite a rigorous process for what data should be put into the repository and what should happen to it and how those gaps in data are filled when an EPD doesn't give us all the information that we need. So we start off with a vetting process. So basically it's the minimum criteria for being accepted into the database. Click. So there are situations where a LCA data source or an EPD might be rejected. That doesn't necessarily mean that that we're never going to accept it. We'll give feedback to the person that supplied the EPD and say this is sort of like, this is why it doesn't meet the minimum criteria. Here's what you could do to make it acceptable. Click. Then once we've decided that we're going to accept the data source into the database, we then go through a data quality assessment. So part of trying to fill in the gaps and get enough data into the database that it's, has most of the products that you need, we need to accept that there's going to be some cases where we need lower quality data that may not completely represent the products that are in Aotearoa, but they are close. And to help maintain transparency, we're rating the quality of that data, so you can see what's lower quality and what's better quality. Click. And then the last step is localization. So this is the whole trying to make assumptions consistent, trying to make assumptions for future life cycle stages reflects the practices that we have here in Aotearoa. So that could be things like transport distances to site, construction waste factors, service lives for materials, end of life routes, recycling, reuse rates, all that sort of stuff. And then our vision is that, is that a lot of the tools that you might already be familiar with and might even be using would start using this database. So it goes straight into those tools that you've already been exposed to. Click. And as Mike said, it's also going to be freely available. We want it to be as accessible as possible because we want people to use it. Well, it only really works if everyone's using it. It's going to cover the entire building life cycle from manufacturing to end of life, and including Module D, if you're familiar with that. And we also want it to be as transparent as possible. Next slide. So just going through those 3 steps in a bit more detail that we use to, import data, add data, new data to the repository. The first one, vetting, we essentially have a series of qualifying criteria. So these are the minimum requirements that need to be met. These are a draft at the moment. They could change. I'm just providing them as an example. So is the data freely and publicly available? Is it relevant to Aotearoa? Is it a product that's actually used here? Does it comply with the relevant standards that we need it to? Has it been externally peer reviewed? Does it at least report the manufacturing emissions? And it can't include offsetting. Next slide. Then when assessing data quality, I'm not going to go into too much detail, but just so you have an idea what we're actually doing here. Essentially, we have 4 sort of indicators for data quality, which focuses on methodology. So that's essentially compliance with our preferred standards. Geographic, so is the manufacturing sites that are the data represents the ones that actually supply Aotearoa. Technical, do the sort of construction practices reflect what actually happens here, and how recent is the data, because as data gets older, it becomes less relevant as manufacturing processes and construction practices change. And each of those are going to get a rating from 0 to 10. So then on to the localization step. So essentially we're developing sort of a broad set of default assumptions and emissions data for that we can apply to future life cycle scenarios. So that's everything from manufacturing onwards, basically. And we're going to use those to fill data gaps. And they're going to be specific for Aotearoa. They're meant to sort of reasonably accurately affect what we actually do, reflect what we actually do here. And so we're actually going to use them to assess, are the assumptions that's been made in EPDs actually realistic? And if they're significantly different from what the defaults are, and they haven't sort of provided a robust evidence to suggest why that should be, then we may actually just reject those figures in the EPD and instead use our defaults instead. Next slide. So just to give you an example of one of these localization things that we have to do, and because I know that this is a topic that some people are interested in, where we have to do some localization for biogenic carbon. So to give a very simple overview, click again. So biogenic carbon, as it's defined in the primary standard that we follow, EN 15804 plus A2, is when carbon dioxide from the atmosphere is sequestered or taken out of the atmosphere from things like trees when they're in a sustainably sourced forest and it's been certified with an FSC certification or PEFC certification. And that's carbon dioxide stays locked within the timber or other sort of other plants. And then click. It's manufactured into a product. Click. And then that carbon dioxide stays within the building product in the building for the lifetime of the whole building. Click. And then the sort of challenge that comes in this area is at end of life and what happens to that carbon dioxide that's stored within the timber. Currently, under the standards that we're meant to follow, we're meant to assume that all those that carbon dioxide is released back into the atmosphere. So it kind of can't, in some ways, it sort of cancels out the benefit that you get at the manufacturing stage. And the reason why it's done like this is because the standard that we follow was developed in Europe. And basically over there, they incinerate a lot of their waste timber, which practically means that the CO2 within that timber is actually released back into the atmosphere. So it makes sense to do that over there. But in reality, there's a few different scenarios that could actually happen to that carbon dioxide. So click, it's stored in the timber. So it could be emitted through burning for energy recovery or decomposing in landfill. Click. But if you're reusing or recycling the timber, it could be what we call transferred, or it exits the system boundary. So we sort of say that it's a positive number because we want the next building that uses that piece of timber to be able to claim the benefit of the sequestration that occurs during the product stage or the A1 A3 stage. But it doesn't. Realistically, it's not actually an emission into the atmosphere. Click. Or it could be stored in landfill. We do have some evidence over here in Aotearoa that the amount of biogenic carbon or carbon that is released back to the atmosphere while the timber is in landfill, especially treated timber. Untreated timber, not so much, but treated timber is actually quite low, and that carbon dioxide can stay in the stored within the earth essentially for quite a long time. And so in New Zealand, we typically landfill a lot of our timber. So this whole assuming that it's all released back into the atmosphere may not necessarily reflect what physically happens. So click. So for example, within the repository, we're adopting a different approach to account for this based off an approach done by Ricks. We're essentially we're splitting C3 and C4 into C3.1 and C4.1, which accounts for the emissions that are actually emitted, or the carbon dioxide that's actually emitted. And then we are reporting different numbers for carbon dioxide that sort of leaves the system boundary of the LCA, but is not an actual emission. Click. So what have we been doing and where are we going? So here's a bit of a progress update. So we've gone through and so far we've gone through and reviewed BRANZ's data, and we've also invited industry to submit new data. So we've gone through line by line through BRANZ's data, interrogated it, had to find a lot of alternative data sources and updated it. It's been a lot of work, but that process is essentially complete now. Currently, we're building the database itself. We're also further refining the data preference framework, and we're developing the defaults that we're using to fill data gaps. And then the next steps are to populate the repository once the database is built. We're planning for our first release of the sort of initial or beta version in mid-2025. We want to establish a governance group so that it's not just BRANZ or CIL that have sort of, guiding this thing. We want industry to help guide this thing. Developing APIs so that tools can use the data. And then looking to release a second version at the end of 2025. Next slide. So what's our vision for this? it's great putting, data out there, but we want this to have an actual impact and actually drive sustainability within the construction industry. So ideally, it helps facilitate consistency amongst carbon assessments by having the data available and sort of making it easier to do these assessments. More people start doing them, and it makes it easier to do carbon footprinting. And if more people are doing it and understand how to do it properly, then ultimately we get to lower carbon buildings. But the other impacts we're sort of hoping to have is drive sustainability with manufacturing. So having all manufacturers' data in one place makes it more transparent, makes it easier to compare. Then manufacturers sort of want to publish their data in the database. We've already had some that have contacted us about that. Then that leads to more sustainable products being specified because there's a range of products within the database and people are specifying the ones that are lower carbon. And then manufacturers then have an incentive to try and decarbonize their products so they can kind of, I guess, stay competitive in some ways. So next slide. And finally, so what can architects do? What can you guys do to help with this and really, really push, lead to change within the industry? So first thing is provide feedback on the repository once it's released. We want you to tear it apart and critique it as much as you can. We know that we're not going to have absolutely everything right, but we're going to get to the best version of this thing if we all work together. So let us know what products or data is missing. Let us know if there's any data that's better data available. Let us know whether it's easy to use. Basically, any feedback you have is extremely valuable. Tell the developers of the tools that you're using about it so that they're aware of it and encourage them to use the data. And then encourage manufacturers and product suppliers to get EPDs or LCAs for their products developed. And that's it.
Okay. Thanks, Jared, and thank you, Mike. That was a really clear and really good presentation of your work. So really appreciate that. We do have a couple of questions here, so I'll jump straight to the questions. What about other sustainability certifications? Is the carbon database expected to extend to those and be standardized? Yeah, so I guess are there other certifications that?
Yeah, so I'm guessing as a sort of coming from that we're only accepting EPDs. That's not the case. We want a life cycle assessment or a carbon footprint assessment of a product. It doesn't necessarily have to be an EPD, although we do prefer EPDs. EPDs will tend to get the higher data quality ratings within our data quality framework, but we'll still accept other sorts of studies. But they do need to be compliant with some sort of standard. We haven't sort of finalized that list of standards yet, but it needs to be something like EN 15804, ISO 1440. Yeah, so we are accepting other certifications or other types of documents, but probably will have a lower data quality rating than an EPD.
Yeah, okay. Thanks, Jared. Another question. There's not that many international databases. You presented some of them, but this is world-leading work. Would you consider it to be world-leading? Because there's not many of these sort of nationally.
I would say so, yes.
Yeah.
So the other databases, as I said, they tend to have the benefit of having a lot of EPDs that they can work with. We don't have that benefit. We've got a lot of data gaps to fill, and we don't have as much research into building practices here either. And that's sort of where our key sort of innovation is New Zealandifying everything when we don't have much information. So the other databases, they tend to just collate EPDs. They might fill in some gaps in terms of adding some products that are missing, but they don't really need to do that as much as we need to do here. which is why we're using BRANZ data as sort of the basis of it, because we've been sort of developing that information for the past 12 years.
Yeah, thanks, Jared. And yeah, I guess the question is that you did mention in your last slide how architects can help drive the change, but maybe Mike, you could describe or just explain a bit more what's the role of architects, why now, what can we do as architects to support this work and encourage, that producers produce more EPDs and get on board.
Absolutely. Well, my opinion that architects are keen to lead in new initiatives and challenging convention, and to have a key part in shaping our future. If we don't do it, if we wait for the regulation to come out and being enforced by the building consent authorities, or leave it to a consultant group to come in and take the space, we'll lose the opportunity to really be a key part of driving this forward for New Zealand. I think it's an amazing opportunity for us now to see what's coming, jump in, have a go, get on the internet, become really aware of what is happening and the things that are coming, like the repository. Have a look at the tools that can be used, to suit the particular scale of the business who's doing the assessment. Have those key conversations with clients and other consultants, and the architect is often the lead consultant. You need to keep that, remain the lead consultant in the space and really dictate how you want your project to be formed, and to realise zero carbon or close to it. We've got a few years until 2050, but time goes very quickly. There's a lot to do. So I think it's up to the architects, to take the lead on this. NZIA and CIL and BRANZ and MB, we're all really passionate about this, and we want architects to lead in the space. The challenges out there.
Yeah, thanks, Mike. Appreciate that. Okay, next question. How can we be sure the LCA tools use the data repository correctly?
So we will be sort of working with tool developers to try and make sure that they understand how the data should be used, what calculations need to be done afterwards, and making sure that that is being used properly.
Okay. Thanks, Jared. Okay, and another question here. Are these LCA calculations funded by central government, or is the expectation for the project and client to absorb the cost? In a commercial environment, how are the benefits best communicated? Did you want to answer that, Jared, or?
Yeah, I mean,
yeah.
From the BRANZ side, we're helping fund the continued development of this database. For the architectural practice of whether clients take on, I'm sorry, I don't think I quite understand the question. Is this,
Yeah, I think maybe the tools, or are these LCA tools funded by central government, or is it the calculations that you're doing, or is the expectation for the project and client to absorb the cost? I mean, the data is free.
Yeah.
And then I guess the idea is that you have a tool like one-click LCA or LCA Quick, and the data will be feeding into the tool.
Yeah,
so.
And then I guess it depends whether there is a cost for that tool. Some of them there is no cost, and some of them they do cost. And I guess it changes depending on which one you choose.
And there's another question, I guess it's two questions here. In a commercial environment, how are the benefits best communicated? maybe the question there is around, you know, if you have to charge your client, how can you argue the benefits doing a carbon calculation? Yeah. If you have any thoughts on that.
Well, I think sort of linking it to our high-level goals of mitigating climate change is probably the key way to go. And giving an example of, I guess, how much you could reduce it by, maybe show them a case study of your previous work, or you know, show that you could actually reduce it quite significantly, and it might actually have a reasonable impact on us meeting our goals.
Yeah, I think case studies can be really powerful. Yeah, sorry, Mike. Yeah.
I think ultimately the writing's on the wall, right? This is going to be regulated, and when you put your project together, it will be required to meet a certain number, a carbon number that will have to be displayed to the Building Consent Authority at the consent process. If it doesn't meet the number, then it will not get through consenting. That's pretty much what will happen. Whether the choice for the, you know, for the architects and the designers, do you want to step in and control this? Because every material you select will have an impact on the carbon footprint. So you can either do this and charge for it as a value-add service to the client, or it becomes another consultant or a project manager who will see the opportunity and take a slice of the fee to do this. So therein lies the challenge. It will cost in time and professional fees. So it's about having this conversation, but it will be law. You know, it is coming in. So the choice is who does it. There are practices already who are doing it. The big practices with the corporate clients, you know, the blue chip clients, downtown Auckland, and it's a value add. Their facilities can be, you know, their rental can be dictating a premium because of the quality of the building and getting, you know, a high Green Star rating. That's what it's all about. There are smaller practices that are doing this as well and embracing it. So it just needs to be more of a conversation with the smaller architects and people who are currently uncomfortable or not aware about what's required. And the more tools that are put out there and custom made for people to be a bit simpler and easy to manipulate, that will really help the industry. So that, you know, that's where these external third-party tool providers will need to come in and assist.
Yeah, and I think the tools are developing all the time and becoming, I guess, more intuitive and more user-friendly, aren't they? So,
and you know, probably in my career, I've seen, you know, the architect being the only consultant, you know, along with a structural engineer. To where we're at now, there's a consultant for everything, and invariably the architect's fee is clipped because of these additional fees for consultants, project managers, environmental consultants, etc., etc. There's a huge list of specialists. So the question is whether we want to have our fee clipped again, or do we want to take this on and own what we do and don't leave it to others to have to dictate the process to us, like the Building Consent Authority or the government.
Yeah, and I think that's, you know, that's really the message that we're trying to get across in this whole Demystifying Carbon series is, you know, enabling our members and our architects to have that conversation and be able to do that, at least in the early design phases. So, yeah.
And that's why the NZIA are in behind this project with everyone else. We think it's so important. We're all bankrolling it together. There's no independent funding. You know, and this is for industry good, which is a purpose that, you know, drives both BRANZ and ourselves.
Yeah. No, you're doing great work. Okay, so there's no more questions. I did have another one. I mean, you did give a timeline, but maybe if people are asking, why can't I access the data now? Can you maybe just describe that time frame again for people so they're clear on that.
Well, I guess the hardest thing is the amount of data that BRANZ have had, and quite crudely, there's no database that BRANZ have had access to. It's been in Excel form and sheets and manually put together and challenged, and it gets out of date. It's just a behemoth of a thing they've had to go through, in the order of 4,500 different line items in their data sheet. So that takes time. The other thing is we're CIL are building the platform for this data to come across. We're almost there with the data, working through the last few iterations with BRANZ. Once we have that, we can then transfer it across. That will be the start. It will not be completed. It is a journey, and this is the start. But to make it publicly available, then the building of the APIs and the connectivity for people to be able to download electronically through to their particular tool or to their website or whatever the purpose. Also appreciating this content, well, we have to add, it'll be based on our CBI classification, which all the architects will be familiar. The Masterspec is set up on that. We've got raw materials which we're adding as a new part of the classification, breaking it down to, sand, aggregate, cement, all these types of things. So the industry will be using this as well as the architectural community and others and contractors. So when people are putting together EPDs in New Zealand, they will access the data about those raw products that they use in their built-up system or whatever they're selling. So there's a huge amount of complexity before we can get this thing out there. But the aim definitely is mid-year to get this out there so people can see it, then getting the electronic connection a bit later in the year, around November, December.
Okay.
Yep.
Great, thank you. And I mean, I'm just thinking in terms of, once the database is up and running, as an architect, will you be able to see quite easily, that you said, is it 90% of our products are imported? 80 to 90%, I think it is. And will you be able to see the difference between those international products and the local products and see a benefit in, buying local potentially?
Yeah, so if we have, there's a couple of instances where we sort of have the same products for one manufactured here in New Zealand and one manufactured overseas. And yeah, if you really want to, you can, if the tools import it and give you the option to choose those different data sets, you could, do an assessment, say using aluminium from China or something. And see what that looks like, and then swap it out for aluminium from New Zealand source like TY Point and see how that affects your results. So that there is data for that for some materials, not necessarily all of them, but there are some examples of that.
Okay.
So the aluminium's a great example from TY Smelter. It's one of the best performing plants in the world because it's using renewable energy, hydro. Where overseas it's through different types of energy, which is, like coal-fired plants, etc., not particularly great for the environment. So it should stack up really well. A lot of the New Zealand extrusion manufacturers for their facade industry already use the TY product and have processes for sending back raw material that's wastage, and it goes back into the system. So there are already processes in place for those products.
We within the descriptions of every sort of data set that we have, we do always state where the products come from or where it's been manufactured. So it's always quite transparent as to where it's come from, and that should give you the information you need to figure out. Yeah.
Okay. No, that's great. We'll have to close out there, but thank you so much for your presentations today and sharing your knowledge. I think it was a really great presentation and good introduction to the carbon database. So I wish you luck with it, and yeah, get our members on board and get the NZAA on board. And also note that the next webinar in the series will be with Francisco Cabajal and Emily Newmarch, and they'll be talking about BIM management and life cycle assessments. That's on Thursday, the 5th of June, between 12 and 1. So again, I'd like to thank Jared and Mike for taking the time to join us today, and look forward to seeing you at the next webinar. And ka kite from us. Thank you. Thank you both.